Hello friends. In this video, we will learn about object-oriented programming concepts in Python. Python is an object-oriented programming language. Almost everything in Python is an object with its properties and methods associated with that object. As you know, when we talk of an object-oriented program, there are many concepts: class, inheritance, polymorphism, encapsulation. We will discuss all of this in today's session. The basic starting point is a class. Just to give an example, fruits like apple, orange, banana, grapes, these are various types of fruits. In programming, I can say these are objects. Apple is an object, orange is an object. These belong to main parent class called fruit. So we have a class fruit, and apple is another class which inherits the properties of the parent class fruit. This is just a quick example to explain the concept of class, inheritance, and object. Now we'll see each of them as part of the programming. What is a class? A class in programming, in object-oriented programming, is a user-defined blueprint or prototype from which objects are created. A class will have a method, it will have a constructor by which you can instantiate the object. Now, how do you go about creating a class in Python programming? To create a class in Python programming, the first and foremost is the usage of the keyword class, after which we specify the name of the class. Note the PEP8 convention. PEP8 convention suggests that the name of the class should be written in camel case. In camel case, we write the first character capital, and if there are multiple words, we join them with first character capital. So here you can see my first class. Okay, so here the class which I have declared, my first class, and it has one attribute or one variable, percentage, and the value itself I have hard coded to 60. I run this code, shift enter, and the class is created. Now we will instantiate an object of this class. To instantiate an object of the class, you give the class name and round parenthesis brackets. Here this class has been defined without any constructor or init method. We will see how to write a init method, which is initializer method. However, for now, because we did not declare any init method, by default we will use the basic function call my first class with parenthesis, and this will create an object of my first class. That is called instantiating an object of the class. And from this class object, we will now access the variable percentage, and this is how we access the variable, where we prefix the object name to the variable name by and between that we have a dot. Okay, that was just a quick starting point. Now let's see how to write a init function. All classes, when we declare in Python, we should ideally have a function called init, which is for initialization and setting the default properties of that class object which we are creating. So here I'm declaring a class rectangle init. By default, the first parameter, whenever we declare a method in a class, the first parameter is self. Self, it means the object itself. You can name it self. It is customary in Python programming. You will see the usage of the word self, but you can name it anything. You can say myself. If you use the word myself, then everywhere you have to use the word myself. Okay. Now to create the object, that object may have certain attributes, parameters. There are two parameters, length and breadth. For any rectangle that we create, the rectangle should have a length and a breadth. So we are taking two input parameters. In the init, the first parameter is self, then length, then breadth. Length and breadth we will have to pass. Self will be passed automatically. The variable L, self.L and self.b, these variables are the class instance variables. We will see about class instance variables more in detail in the next example. However, for now, these are the two variables, length and breadth, where we are assigning the values respectively, and we are calculating the perimeter. This is also a class instance variable because it is prefixed by self dot, and area is also a class instance variable. Okay. Now I instantiate an object. Rectangle is the class name. I call rectangle, and because it requires two parameters, earlier we did not have init function. As such, we did not pass any parameter, but this time it requires two input parameters. I pass value 10 and 8. All these variables values will get initialized, length, breadth, perimeter, area, and we can access the values of those object variables using object prefix dot variable name. This code, as you can see, shows the value 10, 8, 36, 80. The calculations all and the assignment statements are self-explanatory for these values. Okay. We have already discussed the usage of self. The self is a reference to the current instance, the current object of the class, and it is always passed automatically to any class method. We don't have to pass it. And as I mentioned, you can replace the word self by anything. So here I will say myself, 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 and here also let me call it, let me change it. Okay. Now if I run the code, this output is also self-explanatory. Now let's try to understand class attribute and instance attribute. Note, here I am declaring a variable class attribute and the value associated is 1000. Then I have a function init, and I'm also having a function get instance attribute. Okay. To create an object, I call the CI attree class with a parameter 10. This parameter 10 will get associated with input variable 1, and here I'm trying to change the value of class attree. It is initialized to 1000, but here in the init function I'm trying to change it to 10. And here self.instance attree, I am associating it with the value 10, which is passed as an input. Now let us see what will be the value of class attree and the instance attree, these two attributes of the class CI attree. The first one, class attree, stores 1000. Reason is this is a class attribute. A class attribute cannot be changed for each object instance created from the class. It will remain same. As such, even though we try to modify the value, this value will not get modified. This variable is actually not the same as this variable. The name appears same. This variable scope is global. If you understand the namespace concept, any function defined outside any variable declared outside the function is global, and this variable class attree would be actually local. As such, when you try to access the value, you are getting the value from here. This is a local variable, this is a global. Okay. Now, when we try to access the value of instance attribute, we initialize it to 10 and the value we get is 10. Now here I'm adding an attribute, instance attribute 2, and assigning it to the string value, and we'll see the dictionary attribute of the object. It shows that there is an instance attribute 10, there is an instance attribute 2, and we did not get the class attribute because these attributes are specific to the object. Now let's call this function which is defined in the class CI attree. We call this function, it returns the value 10. Now one more important thing that we have to understand about class attribute is a class attribute can be accessed even without creating an instance of the object. I can directly refer to class attribute using the class name. So here is the code. However, if I try to access an instance variable, something like this, I get attribute error because it says that it does not have any attribute by this name. So I hope you are getting the difference. A variable declared outside init will become your class variables, and they can be accessed through the class name directly or by creating an object of the class. Whereas any variable which is declared with self in the init function, they will become the instance attributes. I try to call a method using the class name. We can access the methods only through the class object. and that's why you get this error. Now let's understand the concept of inheritance. Inheritance, as you know, is a property of child inheriting the characteristics from parent. The same concept applied to programming, the process by which the methods, attributes, properties of a class, that is a parent class, is inherited by a child class is called inheritance. One example again I have given: apples, grapes, orange inherit certain properties belonging to the main parent class fruits. So here I've taken this example which I liked from this link. It's a simple example which is trying to explain the concept using the mathematics concept of shapes. So here we have a class shape. Shape, when we talk of shape, it has two main attributes. One is the perimeter, second is area. It can be rectangle, it can be square, it can be circle, or it can be any non-standard shape. And then I have here certain more attributes which we can say the shape is filled by some color, it is not filled, what is the color, and so forth. So here we have declared a class shape. There's an initialization method. By default, we are setting the color to black and we are saying filled is equal to false. If these parameters are passed, then the parameter value which is passed will overwrite these values black and false. Otherwise, these will become your default, and we are initializing these parameters. Okay. So here I have declared self dot color is equal to color, and here I would like to remove these underscores. I don't want to have these underscores at this point. There is a concept of dunder, double underscore dunder. We'll discuss that later. For now, let's remove all of this. Okay. Color is equal to black, filled equal to false. This is a class instance attribute which we are initializing. And then we have certain methods. Typically, if you come from a Java programming language, you will know a class has get set methods. Get to get an attribute value, set to set an attribute value. So here I have declared get set methods, get color, get filled, set filled, like that. Okay. Now I have an init method here. This class rectangle is inheriting shape class rectangle, and to inherit properties from another class, you write the name of the parent class in the bracket. Okay, so rectangle is inheriting the property from the class shape, and when it inherits, it will inherit these two properties, color and filled. It will inherit all of these methods: get color, get filled, set filled, and so forth. So what we can do is, we have this functions. What we are going to do is, we will overwrite all of these functions: get color, get, and in along with it, I'm writing functions for length and breadth. Get color, get filled, I'm overwriting. Okay, and these underscores, let me remove you also while I explain. You can type the syntax, the code. You need to pause the video at various points so that you can learn. Okay, all of these I have removed. And now we move to another class, circle, which again inherits things from the parent class shape. And here, note, I am not overriding any of these methods, get or get filled, get color, set filled. I'm not writing those functions here. I'm writing new set of functions. Init, radius, okay. So all of this, yeah. Coming down, we'll create an object of the class rectangle. Area of rectangle, get area. When I call this function get area, it will call the function get area here. Length and breadth, these two parameters are passed, so they will get initialized. And at any given point of time, I have to access those class instance variables. I need to prefix it by self. Self is automatically passed. I repeat once again. Similarly, get parameter, get color, get filled, get color, get filled, all these methods. Here, get color, I have overwritten. When I say overwritten, which means overriding, this get color method is available in shape. The rectangle class will inherit that function, that method. However, I am declaring that method in the rectangle class again. As such, this will be given priority when you create a rectangle class object. And here I call the function setFilled. Before that, I'm calling the function getFilled. Now again, in the rectangle class, we don't have the method getFilled. So in that case, this method of shape class will get invoked. When I call setFilled, the setFilled method from the shape class will be used by the rectangle class because the setFilled method has not been defined in the rectangle class. What I mean to say now, any method which is defined here in the parent class and any properties which are defined here in the parent class will get inherited by the child class. The child class can override those methods and the child class can add its own set of methods and attributes. Go ahead, execute the code, and we get this output 10.5, 2.5. Let me just make it simple. Decimals 10, area of rectangle 10 into 220, perimeter is 24, class of rectangle R1 is green. This one is method has hard coded value green, so it gives you green. False is rectangle R1 filled false. Why it is false? Because when we called the class object instance, we called init without any parameters. When we called init super init, which means the parent class init, we did not pass any parameter, so by default filled is false. And then here we are saying set filled as true, and then once again if I check filled, it will tell me true. Here I have this code commented. Let me set the color. I am setting the color orange. Despite setting the color orange, the color in the last statement is green because the getColor method of the rectangle class has a hard-coded value green. Let us comment this code now and rerun it. This time when we rerun, you can see the output changes to orange because now the method of the parent class got invoked. Great. The code for the circle class is commented. I will let you practice yourself. I just uncomment it and run it once. The output is here. Kindly practice and try to understand it by yourself. Okay. Polymorphism. What do you mean by polymorphism? In simple English, polymorphism means many forms. Now, when it comes to object-oriented programming, there are multiple ways of polymorphism. There are two main important ways, which is method overloading and method overriding. Method overriding is something which we just saw. There is a method which is written in the parent class, and we are writing a method in the child class. In that case, the child class will use its own method and not the parent class method. So we are overriding the method of the parent class. That is what method overriding is, and it is allowed in Python. However, the concept of method overloading is not allowed in Python. Let's understand what is method overloading. I declaring a method, let us say add is a function name, and I declare a method add with 2 parameters, and then I declare a method add with 3 parameters. In other programming language like Java, you can have 2 methods with different number of parameters. However, in Python, it is not allowed. So in Python, you do not allow method overloading. Why it is not allowed? Because when I declare a method define add with 2 parameters, and then I have another method with 3 parameters, the second method will override the first method, which means the moment the second time I create an add function, the first function will get lost. So only the second function will remain. So we do not have this overloading functionality in Python. The other type of method overloading is, in other programming language, you can have a function which takes, say here int is a function which takes a floating point number as an input, and you can also have a function in other programming language, not Python, where you have same function taking only one parameter, but the data type is string. In Python, these kind of method overloading is not there. But at the same time, in Python, we do not have data types being defined, because at runtime, depending upon the value associated with a variable, the data type is defined. So we do not have these concepts of method overloading in Python. So types of polymorphism, there are 2 types: method overloading, method overriding. Method overriding is allowed in Python. Now there is another important concept in object-oriented programming, which is called encapsulation. Encapsulation, as you can understand the dictionary meaning, some enclosing something in a capsule. For example, when you take a capsule, the capsule contains the powder, the medicinal powder, and all the properties of treating you is all hidden in that capsule medicine. Similarly, in programming, the concept of encapsulation is a way of hiding or restricting direct access to variables or methods. So I have a complex logic. For example, I have some functional requirement, and the entire functional requirement has lots of complex logic. But to you as a user, you just have to call the function name and pass appropriate parameter. The complexity is hidden. In simple terms, this is encapsulation. Now, in programming, the other way of looking at encapsulation is restricting direct access to certain variables of the class instance object. And there are various levels of encapsulation depending upon the access modifier. The three main types of access modifier are public, private, and protected. Anything which is public is actually directly available. Anything which is private is not accessible directly. And protected is in between the public and private. Now, these are concepts of object-oriented programming languages. However, I have not seen these concepts being actually directly applicable in Python programming. They are much evident in Java programming. As such, we will not get into this because it is not applicable here. However, what is applicable in Python is dunder methods and dunder variables. Dunder is because of the double underscore. When you declare certain variables and methods, you can have a double underscore in prefix and suffix, and those becomes your dunder methods and dunder variables. We have this concept. We will discuss this concept. I repeat, we will discuss this concept at length in our upcoming video. Thank you. If you really liked the content, I request you to like the video. In case you want me to make a video on specific topic, you have some specific topic suggestion on which I should be making a video, then please drop a comment in the comment section. Thank you. Bye bye. See you in the upcoming video.